Welcome to EduAmp. This is a GCSE physics lesson and it's all about atmospheric pressure. What I hope you'll be able to do at the end of this lesson is describe a model to explain atmospheric pressure and explain why atmospheric pressure decreases with height. Now, in the previous part of GCSE physics, you may or may not have tackled pressure and seen a pressure equation that pressure times volume equals a constant. So some of this may not be brand new to you, but it's a good opportunity to recap. So this simulation here nicely shows you what creates air pressure. So what you've got here is a container. Don't worry about the little man here, use these for something else. But what you've got is a container and it's empty, it's a vacuum, there's nothing there whatsoever. And here you've got a super duper pressure sensor. It's measuring ATM, and that is actually atmospheric pressure. So basically it's on zero at the moment because nothing's there at all. So what you can do is pump in some air particles. Now, when you pump the air particles in, you probably notice I'm starting to get a pressure reading. And the pressure has been detected, and it's been detected because these particles are creating air pressure. Well, why are they creating air pressure? Well, if you look at these particles, that you should know that particles in a gas are quite far apart and they're moving very quickly. Hence, they start hitting the walls of this container here. Now, if they hit the wall of the container, they then are going to exert a force. And because they exert a force over an area, pressure equals force divided by area. Hence, we start getting pressure. Now, don't worry too much about the units at the moment, but what we're picking up is about 0.3 ATM. Now, if I pump in more air, doesn't this make sense? I've now got more air particles. Won't have more particles hitting the wall. If more particles hit the wall, I'm going to have a bigger force. If I've got a bigger force, I'm going to have a bigger pressure. And you can see now it's gone right from about 0.3 up to 1.6, 1.7. So this is why we get atmospheric pressure.